Hey guys, this is Carl, and this is week 8, problem number 1. So we want to introduce you to the concept and kind of get more into the detail and granularity of alternative and null hypotheses, both in terms of just general broad concepts, but also in the parameter values. What does that really mean? But we'll start out just kind of jump right into it. So our first question, a recent study found that child safety seat compliance is around 80%, and the state wants to determine whether this statistic has changed. So what is our null hypothesis in this case? But before getting to that, I'm going to emphasize what the null hypothesis means. So what the null hypothesis means, if you can kind of sum it up in a couple of words, is whether or not there is an observed difference or a measurable effect with regard to what you're investigating. So in this question, the recent study found whether or not the recent study found that it's 80% in 2011 in terms of child safety seat compliance, and they want to determine whether the statistic has changed. So what are they investigating? Whether or not this 80% went up or down. It doesn't really matter. They want to know whether or not this even fluctuates. So the null in that case is 0.8, which means that it's the status quo. It is the default position, that there is no change with regard to what you're investigating. And the alternative, as the name implies, is that there is a difference, that there is either it does not equal 0.8, that it could be higher or lower. Just verbally, another question that we usually come around with when you're talking about hypothesis testing is comparing phenomenon, comparing various conditions, types, populations. One example that you can think of when you're using hypothesis testing for comparison purposes is whether or not a low-income population has a propensity or higher probability to use the ER, the emergency room. So, in verbally, what would be that null hypothesis is that there is no observed difference or measurable effect with regard to ER utilization in low-income population. And what does that mean? That proving your test that you cannot statistically infer that a low-income person is more likely to use the ER. Essentially, that's basically what the null is in that case. And the alternative, as you would imply, as it does imply rather, is that there is a highly likelihood, high probability, high propensity for low-income individuals to use the ER. So that's just kind of explaining it real quick in terms of a group, in comparing different groups using a variable like ER utilization and hitting it against a group, various ways for alternative and null hypotheses. And you'll see that these examples that I have right here are very basic, but you can really get complex in terms of what you're looking at and how many null hypotheses, whether or not there's independent and dependent variables, and but all of that is we'll get down the road, but just give you a basics concept and quick discussion about it. But moving on to our second question, an older study found that men who drank at least 1 coffee cup per day had cholesterol levels far below the national average for men, 130. So if you'll notice this difference in the question, that the state wants to determine whether the statistic has changed up here, but here it doesn't say that. So what could we infer? That this is already a completed study. What was the hypothesis in the study? Well, this was our investigative piece. They want to see whether or not 1 cup of coffee per day had a measurable effect, or an observed difference on cholesterol levels. So our null would be the status quo, or no observed difference, or no measurable effect. So for the null hypothesis in this case for this study, it was 130. That there wasn't any observed difference or measurable effect. And likely, as you can tell, what's the alternative? That there was. So it's just very short, brief, that when you're looking at the null, you're looking at whether or not there is a measurable effect. And when you're looking at the alternative, you're really looking at whether or not you're trying to prove that there is some observed effect difference, that you can tell that your research question is proven right in that sense. Going to the parameter value. So what does that mean? Well, usually in terms of the parameter value, it's up here, as we can see. P is the population proportion. So when you say P is 0.8, it's essentially the proportion of the probability of the population that, in this case, going to this first question again, is safety seat compliant. So it's important to note that when sample statistics, that you can do the sample proportion or the population proportion, and the key to tell and to distinguish the two are in your question. So we hope this helps, but just let us know if you have any questions along the way. Thanks much.